Alright guys, welcome back, Ultimate Learning. And we're in the back garden again, so you know exactly what that means when we're out here. You'll notice, look, my neighbour shut his door. I think every time I bring a camera outside, he just runs inside. Can't really blame him. But in today's lesson, I've thought exactly what we're going to do today. And I want to go through with you guys the Reactivity Series. The Reactivity Series is a list of metals that are ordered from the most reactive metals at the top, right down to the least reactive metals at the bottom of that series. And if you want to catch out a video that we did on lithium, sodium and potassium, they're some of the most reactive metals in the Reactivity Series, then just tap the link above and you can watch that video just to see how reactive they are. Now, as we go down the Reactivity Series, the metals get less reactive, and that's why we have things like gold, silver and platinum at the bottom, and that's why we use them in things like jewelry. But today's lesson, what we're going to look at is we are going to look at something called a displacement reaction. A displacement reaction means that a more reactive metal is able to kick out or displace a less reactive metal from its compound. For example, aluminium is quite high up on the Reactivity Series, and if we was to react aluminium with iron oxide, for example, the aluminium's more reactive than the iron, so it's able to kick out the iron from that oxide. And you may remember that from our thermite reactions. Again, if you want to watch the thermite video, I'm going to put a link for one in the description, or just tap the link above here. But looking at the Reactivity Series, you may be asking yourself, well, why do we have elements like carbon or hydrogen in there? Because they're not metals. Well, we can use these elements to extract metals from their oxides. For example, we can use carbon to extract copper from copper oxide. If you mixed some carbon with copper oxide, because carbon's more reactive than the copper, it's able to steal that oxygen. We would say that the copper has been reduced because it's lost oxygen. But we would say that the carbon has been oxidized because it's gained oxygen. Well, in today's experiment, I'm going to show you just how reactive magnesium is, because magnesium's quite high up on the Reactivity Series, and we're going to use the magnesium to steal some oxygen from carbon dioxide, which we know in our videos as dry ice. So that's right guys, today's video we're going to be putting magnesium with dry ice, and we're going to watch how the magnesium steals that oxygen away from the carbon dioxide. And this would be known as a reduction reaction, where the magnesium's taking that oxygen, it's stealing the oxygen because it's more reactive, the carbon's losing the oxygen, and the magnesium gains it. So let's see what happens, guys. Alright then guys, so what I've had to do is dig like a little divot in these dry ice blocks. I've had to put a little divot in, put my magnesium in. Let's light it. Let's light it, put the carbon dioxide block on top, see what happens. Man, do you see that? You see that reaction there? So what we've got there, guys, you've got a mixture of carbon and magnesium oxide. Let's do it one more time. Take a look. Wow guys, what a video we've just done today. But let's just quickly recap what we've learned from our lesson today. Well, we've learned that the reactivity series is a list of metals, starting with the most reactive at the top, going all the way down to the least reactive at the bottom. We've learned that a displacement reaction is where a more reactive metal or element can kick out a less reactive element from its compound. We've also learned that when we put magnesium with dry ice and light it, that the magnesium is reactive enough to steal that oxygen away from the carbon dioxide, which is called a reduction reaction, and the magnesium gets oxidized. All right guys, stay in touch.